2018 question number 2. So we have researchers, they're doing plankton cells. They're counting them at a depth of h meters. The density is in millions of cells per cubic meter. And they give us this function. And then there's some other function for greater than 30, but we're using this function for less than 30. So our first questions are always going to be in the easier interval, which we see that happening right here. So we just need to find p prime of 25. So if this were not a calculator active question, we would have to sit here and do chain rule and product rule. It would be a big mess. But this question is calculator active, as will be your questions on this year's exam. So all we have to do is get that function into our y1. So I've already put it in there because we're probably going to use it several times. So just put it in y1. And then all I have to do is go math 8, because that gives me a derivative. And then I want the derivative with respect to x of vars y-vars function y1. And so I'm evaluating a specific point, which is 25. So at 25, I put there, enter, and I get a negative 1.179. Remembering we usually take 3 decimal places. We're actually required to take 3 decimal places rounded or truncated. So I'm going to start by writing p prime of 25 equals negative 1.179. But here's the work part of this, because of course that's just calculator. The important part of this question is using correct units, interpret the meaning in the context of the problem. And that's a little tricky actually in this one, because things aren't changing with respect to time. They're changing with respect to depth. The independent variable is depth. And that depth is measured in meters. And then the density that we're measuring is millions of cells per cubic meter. So what this p prime of 25 is really telling us is that for every meter we go down, we are going to have less plankton density by amount of negative 1.179 million cells per cubic meter. So one way to say that would be to say that at a depth, because we have to reference this number where we're evaluating the derivative. At a depth of 25 meters, the density of plankton is decreasing. So we want to say decreasing because the p prime is negative at a rate of, and we want to make sure that we use the word rate because we're showing that we understand what a derivative is. It's the rate of change. 1.179 million cells per cubic meter. That's just the density, but then I'm going to write this for now. For each meter increase of depth, and we would probably get the credit for saying that we're looking at as a density. So if we think of density as being like a capital D, it's dd. dH, and that density is already being measured in millions of cells per cubic meter. But then what our height is measured in is also meters. So when we put these units together, we're going to have millions of cells per meter to the 4th power. So another way we can say that, I think we would probably get full credit for just saying this, but another way to say this is, or the rate of change of density is negative 1.179 million cells per meter to the 4th power. I think this one's sort of a little bit more abstract, what does that mean, meters to the 4th power? So I like the way this breaks it up better, but either way, you're sort of explaining that what it means. This negative 1.179 means that at that particular depth, 25, we can say the density is decreasing, or we can say the rate of change of density is negative. We can say that it's decreasing at a rate of 1.179 million cells per cubic meter per meter, or we can say it's negative 1.179 million cells per meter to the fourth. Another difference here, I said rate of change is negative. Here I said decreasing, and then I didn't say negative. So if I say it's decreasing, then I don't put a negative here. But if I just say rate of change, I want to put a negative there. So I think either one of those, that's basically like an either or right there. One of these two ways would be a good way of saying it.